Hello everyone, I am Latarani, Assistant Professor of Mathematics. In this video, I will discuss about the topic trapezoidal rule in numerical integration. In the previous classes, we learned about some concepts: finite differences, forward differences, backward differences, Newton-Gregory forward formula, Newton-Gregory backward formula, and also we derive the formula, that is quadrature formula. By using this quadrature formula, we derive the four rules: trapezoidal rule, Simpson 1/3 rule, Simpson 3/8 rule, and also Wedel's rule. But today in this session we derive the trapezoidal rule and working some problems on trapezoidal rule. Let us consider quadrature formula. The quadrature formula is given as integral from x0 to x0 plus nh f of x into dx is equal to n into h times y0 plus n by 2 delta y0 plus 1 by 2 factorial n square by 3 minus n by 2 delta square y0 plus 1 by 3 factorial delta cube by 4 n cube by 4 minus n square plus n into delta cube y0. Put n is equal to 1 and neglect the higher power terms delta square, delta cube, so on. We get integral from x0 to x0 plus h f of x into dx is equal to n as in a 1, therefore h y0 plus n by 2, that is 1 by 2 delta y0. Here delta y0 is in a y1 minus y0. Substitute this value here and simplify. We get h by 2 y0 plus y1. Now similarly this can be written for the another integral x0 plus h to x0 plus 2h, because here n is equal to 1. Therefore here in the previous it is varies from x0 to x0 plus h. Here x0 plus h to x0 plus 2h. f of x into dx is equal to h times, for this corresponding y value is y1 plus 1 by 2 times its corresponding value is y1, that is delta y1. But delta y1 is equal to y2 minus y1. Substitute the delta y1 value, then simplify. We get h by 2 y1 plus y2. Apply the same process up to n minus 1 to n terms. We get integral from x0 plus n minus 1 into h to the x0 plus nh f of x into dx is equal to h by 2 y n minus 1 plus yn. Adding the above integrals, we get integral from x0 to x0 plus nh f of x into dx is equal to, in all the integral h by 2 is a common factor, take outside. Here h by 2 times y0 plus yn plus 2 times y1 plus y2 plus y3 up to yn minus 1. This formula is called as a quadrature formula, trapezoidal rule. The formula of the trapezoidal rule is given by integral from x0 to x0 plus nh f of x into dx is equal to h by 2 times sum of the extreme ordinates plus 2 times the sum of the remaining ordinates. Now we move on to the example. Here first one is evaluate integral from 0 to 6 1 by 1 plus x square into dx by using trapezoidal rule. In some of the problem n is given. If n is not given, we have to make a choose. Here let us divide the interval 0 and 6 into 6 equal parts, that is n is equal to 6. Therefore each of the width h is equal to b minus a divided by n, that is 6 minus 0 by 6 gives 1. And here f of x is an integrand. F of x is equal to 1 by 1 plus x square. Now construct the table. X takes the values from initial values in a 0. It commencing from 0 to 6 of the width h is equal to 1. See, 0 plus h is 1. 1 plus h is 2. 2 plus h gives 3. Again 3 plus h gives the 4. 4 plus h 5 and 5 plus h gives 6. Now find out the corresponding f of x value. Here f of x can be taken as a y of x. Therefore for x0 we get y0 value, for x1 y1 value. Like that y2, y3, y4, y5 and y6. Now write down the trapezoidal rule formula. Integral from 0 to 6, 1 divided by 1 plus x square into dx is equal to. For this, trapezoidal rule is given by h by 2 times the extreme values are y0 plus y6 plus 2 times y1 plus y2 plus y3 plus y4 plus y5. By now enter these terms, then simplify, we get the approximate value 1.4108. This is the approximate value of integral from 0 to 6, 1 divided by 1 plus x square into dx. Now we move on to the another problem. Integral from 0 to 1 e power x into dx approximately in steps of 0.2. In this problem they given h value. Here h is a 0.2. Here h can be defined as a width, length or steps of, like that. Therefore consider h is equal to 0.2 and y of x is integrand e power x. Now we construct the table containing x value and y of x value. Here x is a starting from the initial value, that is a. Here a is in a 0. This a is a added with h gives x1 value. 0 plus 0.2 gives 0.2, that is x1. Then x2 is a x1 plus h. 0.2 plus 0.2 gives 0.4. Similarly x3 is in a 0.6, x4 is in a 0.8 and x5 is in a 1. Now find out the y value. Here y is e to the power of x. Put x value in e power x, then we get the corresponding y value y0, y1, y2, y3, y4 and y4. Now write the trapezoidal rule formula. Integral from 0 to 1 e power x into dx is equal to h by 2 times y0 plus y5. Here extreme values in the previous table is y0 plus y5 plus 2 times the sum of the remaining ordinates y1, y2, y3 and y4. Now substitute the values of these elements and simplify. We get the approximate value 1.72197. This is the value of integral from 0 to 1 e power x into dx. Thank you.